Hello everyone, my name is Faizal Ahmed. I am working in GEMS education. I am a software architect working in GEMS education. I have 10 years of domain experience in edtech field. So I'm also I'm a software developer, not a pure AI architect. I'm also like my project. I'm trying to adapt AI into my applications. So since we have a lot of projects running in our in our company. So we would like to include a adaptive learning system in the LMS module. So that's how we identified and we wanted to develop a adaptive learning system. Okay. Here in this project, we are using two models, the LSTM model and random forest model. LSTM model is it's for sequencing the models, and for random forest is to identify and predict the performance of the students. Let me go into the code. As the tech stack, I'm using Flask as the front end, and the back end I'm using Python.
Flask and Python both are backend. What's the UI in this one?
It's HTML.
HTML.
Yeah, HTML.
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 Just pure HTML.
Pure HTML, and using some JS for bringing out
Flask.
Flask. If you see the AI, these success predictions, and the learning outcomes is to come from the models. Rest all are calculated on the back end. Rest all data are calculated from the back end. Let me walk through the code. I have 5 classes defined. AI model class, student class, analytics, adaptive learning system, performance monitor, and data processing. The AI model, I have 2 classes defined. One is for LSTM, and another is for random forest. Okay. So this is how we create the model, LSTM model. We initially we created with 64 neurons, and then we after creating that output, we are dropping out 0.2 to avoid the overfitting problems. Then again, we are creating another layer of LSTM model with 32 neurons, and then we are reducing it again with 60 neurons and activating ReLU here, and then we are again dropping out 0.2% to avoid the overfitting problems, and that's how we are processing the model, processing the LSTM model, and then we create a definition for random class classifier here with 100 estimators with max depth as 100 and random status 42, and then we use we define a function to train the model. you go to this function, see, I mean, here we are taking the, when we are actually simulating, we are not passing the 100, real time data here. We are just simulating the number of students to train the model. So in this example, we are passing 100 students, and for 100 students, we are creating the training data for both the models. So this training data X and Y is for LSTM, and this training data for random forest, and we are sending as an output from this function. And then we are preparing the student sequence and sending it. Let me explain the flow here. Yeah. Uh, in the front end, we are testing with 3 students: John Doe, Jane Smith, and Mike Johnson. Initially, from the front end, we are passing this. We are calling this API to get the student details. With the model configured, we will be passing the student information and from the LSTM. We will be getting the performance prediction as output here, and the recommended topics also. Recommended topics we will be getting it from the random forest. Once the data being retrieved from the front end, we are loading all the data and displaying it in the front end. This is how success prediction is shown here, and knowledge mastery and learning velocity is being displayed here. And these are the updates, status updates coming from the random forest. It is giving the time warning. The student has taken extended time spent on math.
What's extended time over here? I didn't understand the concept.
Extended time is the student is taking extra time than previous sequence. Like let's say he completed a max topic for let's say for 1 hour. This time he is taking like 1 hour and 30 minutes to complete the task. Yeah, task is nothing but exam or activity, whatever we can define from on the system. And this is the recommended learning path. This is coming from the random forest model, and it says the student for the biology exam, the student difficulty level is 60%, but he is 81% readiness. Readiness for the exam. And from the front end, we are simulating the task. Like I kept the delay for almost 30 seconds. For each 30 seconds, the students will be completing one task, and these tasks will be sent to the backend and update the knowledge base. That's how success prediction from the initial it is keeps on increasing now, because the student is adding the good marks here, getting the good marks. So success prediction, it is updating the model and it is increasing the success prediction, and knowledge mastery also it is getting increased. Right now, since the student has done all the exams, now there is no recommendation from the model. Since I mean, after his readiness for all the exam is fine. So there is no recommendation on the system, from the model. Any questions?
I have a question. So
Yeah.
I'm assuming you're using some form of ensemble model, like just combining the
LSTM and random forest.
Why did you pick those two algorithms specifically? Was it because it's going to
LSTM is the long short memory, right? So it works well for the sequence. So we have 5 features. We are doing the predictions like marks, progress, and the time spent. So for these 5 factors will be sent as a sequence to the LSTM. Like the students one particular student will have these 5 factors, but he will be appearing for the exam multiple times. So these values should be sent to the LSTM, and this LSTM will learn the sequence and it will predict the next sequence as well. So that's the reason why we chosen LSTM here.
So what kind of improvements did you want to see in this project? Is it the data itself? Is it maybe some other algorithms you want to?
So right now for 100 students only we train the model. In future we'll be training with more student marks. So that's why we have to fine tune the model. We need to find a way. We need to work with the experts to fine tune the model.
Like why those
Yeah, it's doing a binary classifier, and it's actually during giving the learning recommendation learning path, and it is predicting the next outcomes of the student. Any questions?
Normally in like CBSE where majority of the students would be high scorers, or like in the 90th percentile or higher. What
even my sample data also like that. Like most of the students are 90% higher.
For the lower percentile, like the ones
it will recommend the
have is there a chance or is there a risk where it can negatively affect or show a different path for those who are going?
That's what I wanted to fine tune the model based on student IDs, not with the generic data. Like we need to the prediction should be done on the student numbers itself, not on the generic all the student data. That's how we need to fine tune the model. Right now it is based on like we will upload all the student data. We uploaded all the student data to the model. In future I have to do it based on the student level, so that it will fine tune only based, it will get the prediction for that particular student only.
Cool. All right.
Yeah.
We'll
Thank you.